Have you ever looked at a tiny grain of sand? It seems so simple, so solid, but what if I told you that inside that single grain, there is a universe of mystery, a world so strange and so full of unanswered questions that it challenges everything we think we know about reality itself. This isn't science fiction, this is the world of the atom. It's a realm where the rules of our everyday lives simply fall apart. We're going on a journey, not across the vastness of space, but deep inside the smallest things we can imagine. Prepare to have your mind expanded as we dive into the heart of matter. So, what is an atom? Imagine the smallest possible piece of anything, the smallest piece of gold that is still gold, the smallest piece of oxygen that is still oxygen. That tiny, fundamental building block is an atom. Everything you see around you, the chair you're sitting on, the air you're breathing, the stars twinkling in the night sky, is made of these incredible little things. They are the Lego bricks of the cosmos. For a long time, we thought that was the end of the story. Little solid particles, clicking together to build the universe. But the truth, as we would discover, is far more bizarre and beautiful. To give you a sense of scale, atoms are unbelievably small. If you were to blow up an apple to the size of the Earth, an atom inside that apple would be about the size of a cherry. Millions of them could fit on the period at the end of this sentence. For centuries, they were just an idea, a concept dreamed up by ancient Greek philosophers. They had no proof, just a powerful thought. If you keep cutting something in half, you must eventually reach a point where you can't cut it anymore. That final, uncuttable piece was what they called a tomos, which means indivisible. But here is where the mystery deepens. These atoms are not solid, indivisible specks at all. They are mostly empty space. At the center of this vast emptiness is a tiny, dense core called the nucleus, and swirling around it, in a strange and ghostly dance, are even smaller particles called electrons. The space inside an atom is so vast, relatively speaking, that it's like a single fly buzzing around inside a massive cathedral. The solid world we touch and feel is an illusion, created by the energetic dance of these tiny particles in their vast, empty arenas. It's a cosmic ghost story happening all around you, all the time. For a long time, scientists pictured the atom like a tiny solar system. The nucleus was the sun, and the electrons were planets orbiting in neat, predictable paths. Or even simpler, they thought of atoms as tiny, hard billiard balls, bouncing off each other to create the world we know. This was a comfortable idea. It made sense. It followed the rules of our big, everyday world. Scientists like John Dalton and later Ernest Rutherford helped build this picture piece by piece. They gave us a model that was orderly, predictable, and fit well with the physics of the time. This simple model worked for a while. It explained a lot about chemistry and how different elements behave. It allowed us to understand why wood burns and iron rusts. But science never stops asking questions. As our tools got better, we started to peer more closely at the atom, and when we did, we found that the neat planetary orbits were not there. The little billiard balls were not so solid after all. The comfortable, predictable picture of the atom began to crumble, revealing something far more puzzling underneath. The closer we looked, the less sense it made according to our old rules. The big change came with a new kind of science, quantum mechanics. This is the science of the very, very small. And it brought with it a whole new set of rules. Rules that sound like they come from a fantasy novel. Quantum mechanics told us that we can't know exactly where an electron is and where it's going at the same time. The more you know about its position, the less you know about its speed, and vice versa. This is called the uncertainty principle. The atom wasn't a tiny solar system, it was something more like a fuzzy, uncertain cloud of possibilities. So, instead of a planet following a specific path, imagine a cloud. The electron isn't in one single spot within that cloud. In a way, it's in all possible spots at once. The cloud just shows us where the electron is most likely to be found if we were to look for it. This was a huge shift in thinking. The universe, at its most fundamental level, wasn't a clockwork machine. It was a game of chance, a world of probabilities and ghosts. The solid ground beneath our feet was suddenly made of clouds of possibility. The atom had become a place of deep, undeniable mystery. Welcome to the quantum dance. Here the partners are particles, and the steps defy all logic. One of the strangest steps is called superposition. This is the mind-bending idea that a particle, like an electron, can be in multiple places at the same time. It's not that it's just moving very fast between two spots, it is literally in both spots and many others all at once. It only chooses a single location when we try to measure it or interact with it. Before we look, it exists in a state of pure potential, a wave of all possibilities. Think about it this way. Imagine spinning a coin. While it's spinning in the air, is it heads or tails? In the quantum world, the answer is both. It's only when the coin lands on the table, when we make a measurement, that it has to be one or the other. This is what's happening inside every atom, all the time. Every electron, every particle is a spinning coin of possibility. The universe is constantly holding its breath, waiting for an observation to collapse the wave of potential into a single, concrete reality. This is not just a theory, it's a fundamental aspect of how reality is built. And the weirdness doesn't stop there. There's another spooky phenomenon called quantum tunneling. In our world, if you throw a ball at a wall, it will bounce back. It can't go through the wall unless it has enough energy to break it. But in the quantum realm, a particle can do something impossible. It can arrive at a barrier it doesn't have the energy to cross, and then suddenly, it can appear on the other side. It's as if it tunnels through the solid barrier, disappearing from one side and reappearing on the other, without ever having been inside the wall. This isn't just a quirky trick. Quantum tunneling is essential for life itself. It's how our sun works. The sun generates energy by fusing atoms together in its core. But the atoms don't technically have enough energy to overcome the forces pushing them apart. They get close, and then, thanks to quantum tunneling, they simply pop through the barrier and fuse together, releasing the immense energy that warms our planet. The light on your face is powered by a quantum impossibility, repeated trillions of times every second. The universe is built on these strange and wonderful rules. Even with all our incredible theories and powerful machines, the atom still holds its deepest secrets close. Quantum mechanics gives us the rules for the dance, but it doesn't always tell us why the dance is this way. Why does looking at a particle force it to choose a location? What exactly is this observation, and does it require a conscious observer? This is one of the biggest, most profound mysteries in all of science. The very act of looking at the universe seems to change it. We are not just passive viewers of the cosmic drama, we are participants in it. Furthermore, we've discovered a whole zoo of particles inside the atom, but we don't know why they have the specific properties they do. Why does an electron have the exact mass and charge that it does? Why are there these specific families of particles and not others? And then there are the great cosmic unknowns like dark matter and dark energy. These mysterious substances make up over 95% of the universe, yet they don't seem to be made of the atoms we know and understand. The matter that makes up you, me, and every star we can see is just a tiny fraction of what's really out there. The journey into the atom is a humbling one. It shows us that with every answer we find, we uncover a dozen new, deeper questions. Science is not a book of facts, it's a method for asking questions. It is a process of exploration driven by the most powerful force we know, human curiosity. The atom teaches us that the universe is not only stranger than we imagine, it is stranger than we can imagine. And that is a wonderful and exciting thing. It means there are endless frontiers left to explore, both in the vastness of space and in the tiny universe within a grain of sand. So, keep asking questions. Look at the world around you and wonder how it works. The story of science is your story. The story of our quest for knowledge. It's a journey we are all on together. If you found this exploration into the quantum world as amazing as I do, share this spark of curiosity with others. Let them know there's a universe of mystery waiting to be discovered. Be sure to follow along for more journeys into the cosmos, because the next great discovery could be just around the corner, waiting for a curious mind to find it.